Hi guys, my name is Abdurrahman Gilal, and in this video I'll be explaining you queues and stakes in Java. Both of them are data structure. In our previous video, we learned the data structures name, array list, and linked list. So both of them are basically implemented over the list interface. So we realized that both of them are having their benefits and pros and cons. So for example, we knew that this is the array list, for instance, and if we are supposed to add an element here, such as 4, so array list is a little bit expensive for us because it creates another array list first, and then it brings in the the element into it, and then it removes the previous list. But linked list is quite faster in that, because linked list works on a concept that is called node. And in the node, typically we have three units. One is called data unit, another one is called next address, and the previous address. So next address indicates that where actually our next element is available. For example, this is the element, and if this is going towards the B, or this is called 2, sorry, this is going towards the 3. That's something similar, but here we have all it like continuous addresses available. So everything, for instance, from 1 to 4 or 1 to 3, it's easy for us to traverse because we know that let's say if it's integer, or let's say 8 bytes or whatever bytes. So it's easy for us to know, like, if this is at address number 1, then this will be at address number, let's say, 16 or whatever. It depends the size, right? But it's not pretty straightforward, because this here, all elements are at one place, but in a linked list, the elements are at different addresses, but they are connected through the addresses. So what I was saying, that's effective in adding and removing, for instance, that you wanted to add the element called the node called 4. So now what you have to do is to just change the address, the next address from here to here, and then this will bring the next address here. So this will be eliminated. So you see that in this way, we did not disturb too much of the linked list. But here we have to duplicate everything, which is going to be costly. But like, the benefit is, like, traversing is quicker here. Adding and deleting elements in the linked list is faster. So it depends what is your program need. But in any case, like, queues and stakes are a bit different than them. They do not work on more on like how to, make a relation between the elements, but more like how to make the elements available for their operation. So let's say if I'm saying queue, it's the same thing, that if I have three tasks like T1, T2, and T3, which operation should I perform at what time? So that's where I have to decide, like, which data structure I'm going to use. Or let's say if I have a data available in T1 and T2 and T3, which data should I be executing first and later? So these two concepts are going to help us to implement during, I mean, in our programming, uh, you know, programming concepts. So let's say in the queue, let's say anybody who comes first goes first. So it's called LIFO. Sorry about that. So it's called LIFO, means sorry, FIFO, not LIFO. LIFO is your stake. So FIFO means first come and first serve. So you come first, so you are served first. So any data or any data that is available for manipulation will be performed first. So where do we use that? We use it in, let's say, the data that is available for us, task scheduling or something that is there. So we see, like, whatever had come first in the queue will be executed first. So let's say if we had an array, so it is considered like it has opening from one side, and then exit from another side. This is open and this is exit. So which means that if my element is here, let's say 1, then 1 will be pushed forward, 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 and goes out. So that's how it looks like. So if I make this my element, so it depends like this. It depends how you represent. In a simple word, anything that comes first has to go out first. We will realize that we're gonna have a lot of places where we have to, use this type of concept. But there are some situations where we have the concept that is called stake concept, which I was confused a bit that here, like I said, LIFO. So LIFO is this one, then last in and first out, which means anything that we throw in here, let's say I throw A here, so A is like here, and then I throw B, so and then I throw C. So now the bucket does not have any other opening. It is closed down here. So you only if you wanted to take out anything, you want to push out, let's say. So that is possible from one end. So insert and exit is from one end. So the data or any task that has come at the end will go first. So let's say A came first and then A has another data over it that's called B or task or C. So this concept is called push when we put the data or put the task, and that's called pop when we take out the data. So that's all like it looks like. It's pretty straightforward in seeing, but let's say with the help of the current or advanced libraries available for queues and stake, it is pretty straightforward. So I'm not gonna go into too much detail of explaining that how the data structure works behind the scene, but just in case that we will learn that how to implement the queue. So you should know that a queue is something that whatever comes first goes out first, and in the stakes, anything that comes out first will go last. So last come first serve or first out. So but because both of them are implementing a bit similar ways, so output may be similar, but I'll be explaining you how it looks like. So let me quickly start coding it. Okay, so first of all, we have to, give me a second. Yeah. So I'm gonna be going side by side. So in order to implement the queue, let's say queue, what we have to do is to call the class queue, and then what queue are you making? I'm gonna make integer, the same thing that we have to have the wrapper class for integer. We can't use int. So we have to say it's integer, and then any name that you want to say. So you say this is called queue. And then here you have to tell us that based like on what you're going to implement the queue. So you have array deque and then you have linked list, but I'm going to go for the linked list because I have already explained you the linked list. So we are going to implement on the linked list concept. So how to work on the stakes. So it's the same thing that we used stake class, and then we have to use the wrappers, and then I'm gonna say that's my stack, and then same thing new, and here you can use stacks because this is working on vector, so we can use stack. So slight difference here that here we are using Q class with the linked list, and then here we are using a stake with a stake. So that's just a simple difference. And here how you add the elements. So let's say you're gonna add the element, let's say as soon as you hit the dot operator, you're gonna get this method called add, and there is a method called offer. Both of them work, but one of them is you know good on another in different situations. So I'm not gonna explain right now, but let's say you're gonna add the, let's say, one here, and then you're gonna add the, let's say, two here, and then you should add three here, so that we are having certain data to see like how they work later on. So let's say now I wanted to print out. So let's print out the queue. And in order to make it look good, so let me just have this. Okay, so now I'm gonna add data into stake. So how am I gonna add data? The same way that I'm gonna say stake. And the best way is to use, you can still use add, but I would use push because as I told you that in here also we can use offer, but push is the better way because that's a concept that usually developers use with the stakes. So we use push stake, same thing, then we push again, and then we push again. So with this way, we have same thing that is there in the queue. And I'm gonna say stake and stake. So let's see the output. So we're gonna see like, okay, perfectly fine. Both of them added the values. What if it could be tasks? Like sometimes we have seen like in exception handling, we found an exception called stake overflow. So stake overflow is something that basically happens when the operations are, crossing the size of the bucket that any program gives us. So that's okay. Now let's try to how to say use the element. So how can we use other methods available? So let's say I'm gonna use system.out so that I can show you like how to see the size in both of them. So I'm gonna say q.size. Yep, that's the method, q.size. So better I use the q size. Q size, and then let's run it here. It's the same thing gonna be, we're gonna say like stake size. Yeah, so the same method, the same thing as I told you. So size will let us know. Definitely there will be size, like, you know, didn't we have, okay, here's print element better. Yeah. So we could see that Q size is 3. That's okay. And stake size also 3. So sorry about that. So we know that, okay, it works fine. So let's now, like try to take out something from that, from the from the stake or in queue, because that's the place where when they go together. So I could see like in queue I have 1, 2, 3. So if I'm gonna take out, let's run it first. Let's organize it better. Okay, now you see here, if in queue one went first, second went second, and third went the last. And stake also, but in the stake we have realized that in stake last in first out. So let's run it first. So now I'm gonna say, so basically in queue, when we wanted to take out the data, so we usually say a word called pool. So anything that is like available in the queue, the pool will be helping us to take. So we knew that the first one came first. So, but it does not just take out, but it eliminates the element, which means that one is coming out here as well as one goes out from the queue. So better I call it here. So you're gonna see like, okay, where exactly did it go? So now I'm gonna print our queue, which is simple. And in stakes, we use the word, we use a method called pop. That's what we have just discussed. I'm gonna say pop. So pop will just not take out the element and also delete the element from the list, which is a stake list. So let's say in both, so we're gonna now print a stake here and a stake there. Let's run it and see. So you see here, 1 came first, 2 came second, and 3 came last. So the size was 3, that's true. So when I say do the pop, the pool here, so in the pool, it gives me 1, that's true, because 1 was my value, because it came first. And then it has eliminated the 1 from the list. Same goes with the stake. We have 1, 2, 3. The 3 came last, and we remember that the LIFO, the stake uses the concept called LIFO. So when we try to pop, so it basically took out 3 because that's the last one and give me the remaining elements available in the list that are 1 and 2. So this is something very important in stakes and queue, that a little bit tricky here. So when we try to take out the element, the indexes came out from the backward, and when we try to push the element, the indexes come out from the front. So that's that. Like if I wanted to add any element now in the stake, so where will it be pushed? What is your opinion? Like 1 and 2 is there. So technically, 2 is the second last element and 1 is the, so let me draw it for you. So it looks like this. So now I have Now I have two elements. One is here and two is here. So now if I want to add four, because I have already deleted three from here, so four will be here. So four will be here. So you see one, two, and then we will have four. And that's how it looks like in the previous one, that when we added one, two, three, so three was like this, like one, two, and three. And when we deleted, this went first. And then we are left with this, and then we will add, if we push four, so we will have one, two, and four. This looks like pretty safe hop. And now if I wanted to push a pop, so the pop will be the four first, and then pop will be two, and then pop will be one. So it depends like how and where exactly you wanted to do the pop. So that this is how it looks like. But if the same thing, if you go back, let me clean and explain you there with the queue. Then if you wanted to add in the queue now, so we know that in the queue, we had elements and then we have opening here and then opening here. This is called exit point and this is called entry point. So previously we had one, then two and three. It looks, when we print it, it looks like, okay, fine. But it always sees which came first. So we knew that it came first and this came later and this. So it went out first. So this was called the pooling. So that was the pool now. Now we have this element left, two and three in this way. So now if we put another element that's called 4, so the 4 will still be here. So now if we wanted to pop, if we wanted to do the pooling, so the 2 will go out. So the next list will be then 4 and 3. That's how it like it goes from the pipe. The water is going from the pipe. So any water that comes first has to go first. That's how it looks like. So let me quickly code for you. So here I'm gonna say like, okay, I'm gonna push an element that is called 4, and then I'm gonna say, sorry about that, yeah, and then I'm gonna say updated stake, and then this is my updated stake. I'm gonna see, and then I'm gonna put, I'm also gonna say like q dot aid or dot offer. It's the same thing, and then I'm gonna print out updated what's that, updated queue, and then we're gonna see like how it looks like. So let's see, so let's run it. Okay, so that's perfectly fine. 1 2 3 we saw, size was 3 we saw, first element was 1, that's okay. There are two elements left, 2 and 3. So now it's called 2 3 4 because 1 is already out from the queue. And the same thing goes for the stake now. 1 2 3, that's okay. Size was 3, that's fine. And then 3 was eliminated, definitely, because that was popped. Sorry, yes, not, oh, yep, push and pop, yeah. And then we have 1 and 2 available in the list, but when we pushed 4, so it came 4 here. So this is called updated list. So that's pretty straightforward if you understand the way it flows in and out. But there is another way. Like for instance, there are some situations where you exactly don't want to take out the element. You just wanted to see which element is next in the queue. So when you just wanted to see which element is next in the queue or next in the in the stake, so we have a method called so next element in the queue, let's say. So now we are going to use a method that is called queue dot this one peak. So peak just helps us to bring out the element to show us that this is the element that is coming next, but it does not actually eliminate it from the list. So now if you wanted to say like it's the same thing here, for instance, this one I did like when I did pop, when I did pool, so it basically eliminated the element from the list. But now I did peak, so we're gonna see next element as well, and this the queue will still have the same element. The same thing goes for this. Okay, let me just copy and paste. Okay, that was not a good place for us to print there. So now we're gonna print the same thing here. So we're gonna see like next element in this take. Sorry about that. Yep. And I'm gonna say next element in system. Let's run it. Okay, this is my bad. I should have a stake instead of Okay, let's run it. So we're gonna see that. Okay, so it's pretty safe. Our 1, 2, 3 size was 3. First element was pulled out, and the remaining one is 2, 3. So we added an element that's called 4. So what is the next element in the queue? That's 2. That's perfectly fine. And when I printed the next, how to say, when overall queue, it did not take it out. It showed me 2, but it did not take out. So it's still the element is there. Same thing goes for the stake. So everything is the same, but the order of eliminating the element from the list is like from backward, last in, first out. And when we pushed in, so that's the same thing. And which is the next element in the stake? It shows me 4 that's gonna be go out. That's what we discussed, but it is not out from the element from the list yet because it just peaked. So peak helps us to just see the element, and it helps us to see like uh, if you wanted to do some manipulation or you wanted to do some how to say some pre calculations on the data or something, this is where you're gonna need. So there are so many other methods available for queues and stake. It depends like what is needed. For instance, you wanted to see like queue dot, and then you're gonna see like you wanted to remove something, and you know you wanted to see like if any object is contains, or you wanted to see like is empty. So it just gonna tell you like if it's empty or not. So it returns you 0 or 1, true or false. So it's not empty yet because we have 4 elements here. It's the same thing gonna go happen with this queue. And then because in the sorry, in the stake, and then you also can do more with this, remove all the element, but depends like which elements are you going to remove. So if you have to pass the some list here, or some cues here, so that you're gonna see like I'm gonna show you like what am I mean from the here you have to pass the collection. So let's say you pass the same collection, you're gonna say like you remove the queue. So with this way you remove anything that's there in the list, and then you just remove it. So you're gonna see like which elements are deleted. So these all elements are deleted. So let's say if you wanted to print out if you wanted to print out the queue now, it will be empty queue because it is done. Like this has just deleted all the elements. So this is one way. Like if you have 2 queues, you wanted to compare any element that is there, and then you wanted to just see like just the similar elements are should be deleted. So that's how it looks like. So you just have deleted all the elements, so you don't have any. And this is going to work exactly the same with this. With this queue, oh sorry, stakes. You just do like this. So that's it. And here also. And here you put this. So you can also use like if you have queue here, you can put stake here, or you have stake here, then you can put queue here. It's the same thing, but both of them are list collections. So you see, we're gonna have the same thing. Now everything is deleted. Also, if you wanted to, check like if you wanted to remove particular elements, you can do that. For instance, instead of deleting everything, you wanted to delete some particular elements. So you're gonna go and see like pop or search. So you have so many things to do with that. But this looks pretty straightforward. That once we have stakes and queues in pretty straightforward, last in, first out, first in, first out. But there is another method available, or sorry, it's a technique available, data structure available, that is called DQ. That DQ basically is going to help you to have the double extended queue, which allows you to eliminate and add the elements from both sides of the queue. It is gonna be there in a stake as well. So I'm gonna just quickly, uh, you know, show you an example here. So we're gonna work on this DQ example. Okay, so let's work on this. Public static void main, and then oops. Okay, so here, let's say you want to work on array, not array, sorry about that. So you want to work on queues. Queues, and which queues are you working? The same thing, I'm gonna work on integer. And then what's the name of the queue? You make it cube, and then here, and as soon as you come here, as I explained you, that I have a linked list. Now you work on DQ. Array DQ means double extended queue. It allows you to enter from any side and exit from any side. So it's slightly different from the queue that we discuss here. Then in here only you have all first, last in, or first in, first out. So this is coming from one side and it's going from that side. So first came, this one came first, so it will go out first. This came later, so it will go out later. But let's say in the DQ, I'm gonna say like this as my DQ, just an example. Now this is my DQ. So previously, like I had only this like 8 options, and now I'm gonna say, okay, give me a second. Hi guys, my bad. Actually, I wasn't supposed to create the same name class, which is DQ, because we have already called DQ, a keyword. So better I have created an example here. So I'm just gonna, make it simply, you know, eliminated from our discussion. So let's run it here. So here I have trying to work on DQ, so better I work on DQ. So once again, I have slight changes in the code that is called DQ, and then I have created DQ from the DQ. So let's say now if we gonna say let DQ, so we have now slightly advanced version of Q that's called a double extended Q. So now I can add the first element, for example, 1, that's coming from the how to say from the front, which means like if I have let's say if I have Q side. So this is my first and this is my last. So you should understand this flow. So now if I am saying that it is going from the first, so which means element is going from here. So it's here now. So it's the paradigm remains the same. It's called Q paradigms, first in, first out, but it is just inserting from here. So now if I say element 2 coming from here, so it will go here, but it will be coming from, so it is earlier than 1 now because it's being added to the last. So let's run it and see like how it appears. Okay, so it's just a quick one. So now I'm gonna say 8 from last and it is called 2. So let me print it out first so that we can see like how it appears. Okay, so you see here, as I discussed with you, that if I say 1, 2, so as per understanding, it'll remain the same. But now if I wanted to pop it out, so that's a place where we have to now see like which one be coming. So I do the peak so that I wanted to show like which one will be coming. So the same concept, first in and first out. So this came first. So let's lightly do some more manipulation. So now I'm gonna say 8 at first, and I'm gonna say 8, 3. So now 8 is being first, so it is coming from the first side and it's going to 1 and 2. So 1 was earlier, so I should be expecting that 3 should be later than this. So let's run it. So now here we have element called 3, 1, and 2. Because I said first, so it is pushing the first element here, and then it's bringing it here. So now, though the 3 is added in the last, but because I've enforced it, so it is now, bringing the third as the first element to be eliminated from the list. So this is something like a little bit tricky, that in the queue, in normal queue, if we are working in normal queue, it remains straightforward, 1, 2, 3. So 1 come first, it goes out first, it goes come, so anything like that. But in the DQ, it's a double extended queue, which you added the first, so it remains the first, and you added the last, so it goes to the last. That's pretty straightforward. And as soon as you add another one, let's say you wanted to add let's say now 4. So now 4 will be just simply being added at the end because it's just like working as the first in, first out paradigm. So let's run it and see which goes first now. So it's the same thing, 3, 1, 2, because 1 came first, and then this has influenced the first, and then 2 was just the last one. But because I added the 4 after the last, so basically it's gonna just add the 4 here. So now let's say if I wanted to add 5, DQ 5, so let's say 8 last, so 8 first is better. 8 first, now 5. So what is your opinion? Do you think the 3 will be now, well, 5 will be the first one to be going out from the list? If yes, that's true, because the 5 is now pushed directly into the queue, and that's called first. So it will be starting from the, it will be going into the list from the first, which means that the first in first. So that's a paradigm, right? The principle. So let's say it's like this. So if I have the elements, the first I answered the first, so it came from here, so it was the first one, so it was supposed to go out first. And then I had 2 here, so it was the last one, so it was supposed to go. So that's why when I printed first time, it was showing me that the peak was 1. But now I added, then I added 3 at the first, so it has now changed the appearance. So now 3, 1, 2, that's it appeared. And then I later added 4, so I didn't add any first and last. So by default, anything that is after the end of the list, so it will be 4. And then the fifth element is forcefully added here, so now it's the first element of the list. So the first element is 5, because we have forcefully added the 5 here with the help of DQ. So now when we peak, so the first one will come out, that's a 5. And that's the same thing gonna happen if you have a state. You're gonna do the same thing from the, because stake is also working on a vector concept. So let's say I'm working on integer, and this is my stakes, and I'm gonna say like let's say without even having this double Q, I can like let's say stakes, all right, and then dot aid. As soon as I say it says first, and it is also the same thing, and it'll aid first and it'll aid last. I hope it makes some sense, because it's slightly not similar as we learned first in first out, but with the help of DQ, which is another type of data structure, double extended queue, which allows entry and exit from both sides. So it's also the same thing, that if you peek it, or if you wanted to DQ from the last. So let's say, and let's say you wanted to remove from the last or remove from the first. So you say remove from the last. So last element in the list is right now is 4, should be deleted, and then it's gonna tell us 4 is removed from the list. So if you wanted to print out the list now, so it will be the DQ. DQ will be just having 15312, 5312, because it's, and the same thing that if you wanted to remove from the first, so you just have to do the first. The first element, that is 5 right now, will be eliminated from the list. So we have 3, 1, 2, 4. So the same thing, that is, if you wanted to play around, just go here and see like add, remove, or get first element and get last element. You're gonna manipulate and see and learn more. If you got any question that you wanted to ask, and you got any confusion that you wanted to discuss with me, please do not hesitate to drop me the message. Please take care. Bye bye.